Now we have all the required resources, the network infrastructure, to deploy our first Kubernetes cluster using AWS EKS. To do that, we need to deploy the cluster control plane first. The cluster control plane means etcd database and Kubernetes components, kube API server, kube controller manager, kube scheduler, and cloud controller manager. All of these services will be automatically deployed by AWS in a managed way. And AWS may deploy some other controller especially designed for integrating EKS service with other AWS services that I'll explain all of them later in the course. As EKS is a managed service, AWS makes sure all the components get deployed into the platform in a high available way. And to make these components highly available, EKS deploys etcd database with at least 3 instances and all the other components with at least 2 instances. And then we will get a highly available cluster. So let's get started. If you didn't follow our social media, please follow our LinkedIn, YouTube, Telegram, Facebook page, as well as our Twitter. The procedure to deploy the EKS cluster control plane is to create an IAM role to be used by EKS cluster, because when we want to deploy EKS, the control plane may need to create some other resources in our AWS account on our behalf. For example, to create some volumes, to create some load balancers, to create some route or something like this. And we need to attach Amazon EKS cluster policy to that role. And we need to grant the assume role access to EKS service to be able to assume that role and do all the things on our behalf. And after that, we can create our EKS control plane. To create an IAM role, we need to create a trust policy first. This trust policy mentioned EKS service can assume the role. And now we need to create our role. My role is kubedemi EKS cluster role. And when we try to create it, we get an error because I already created this role in my account, and you can see it here. Yes, this one. And after that, we need to attach Amazon EKS cluster policy to that role. And if we do that and check the role, you can see the policies get attached to the our role. And if we check that policy, you can see it allows EKS to create roles, security group, tags, volumes, and working with the elastic load balance service on our behalf. That EKS needs to do all of these tags for the operation and make everything works. Now, as we have our role for the cluster, we can create our first EKS cluster. This is the diagram of what we did. We created EKS cluster role and attached Amazon EKS cluster policy into that role. And for the trust policy, to assume that role, we allowed EKS.AmazonAWS.com, the EKS service, to be able to assume that role and do all the things on our behalf in our AWS account. Now it's time to create the EKS cluster, the control plane. To do that, right now I'm willing to deploy Kubernetes 1.28 in our public subnets. In a future article, I'll discuss and explain how we can do it in a private subnet, how we can deploy a cluster in a air gap mode without any internet connection. And just to deploy the first cluster, let's do all the things in a public way. So we deploy our cluster with a public endpoint, which means the endpoint is accessible over the internet, and all the nodes will be deployed into public subnets. To create the control plane, we need to run this command: AWS EKS create cluster, and provide all the options and the configuration we want to deploy our EKS cluster. So let's do that and paste it here. Okay, the cluster is get created, and it takes some time to be ready. And if we check our EKS dashboard, we can see the cluster is creating. To check when the cluster is available and is ready, we can also run some command with the AWS EKS wait command to wait for cluster being active. And we mentioned the name of our cluster. As I said, it needs some time to get everything up and running. Okay, in the meantime, I want to show you what we did. This is our current infrastructure. AWS creates all the Kubernetes components in a separate VPC. So you have no any access to all these resources. You can get access to the etcd database, you can get access to the API server, scheduler, or any other managed service, because all of them get deployed into separate VPC completely managed by AWS. And after everything gets up and running, it's create a network load balancer for the API server, and we can connect to the cluster using kubectl command with this using this network load balancer. In addition to that, EKS will create at least 2 ENIs in our subnets, in our VPC, that these ENI connected to the API servers. So if you deploy anything into these subnets, into this VPC, you'll be able to access the API server using these ENIs. And in addition to everything get created for our EKS cluster, EKS will automatically create one security group assigned to these ENIs. In addition to all the nodes, we will deploy using managed node groups. This is our diagram, and now we can check. Okay, it's get creating. We can check it here. It's still in creation. We can also check it here. When the cluster is get ready, this command will be terminated. In the future article, I will explain how we can deploy our worker nodes using different methods, using managed node groups, using custom launch template, how we can deploy our worker nodes in private subnet, how we can deploy bottle rocket uh, worker nodes, and all the major ways to deploy EKS worker nodes. It needs some time to be ready. We can check it here. As you can see, if we go inside, right now we have no any API server endpoint, we have no any certificate authority because the cluster is creating. And after the cluster creation, we can see all the things. And now, because right now the EKS is just the Kubernetes control plane. Right now we have no any worker node, which means we can deploy any workload, any pod to our Kubernetes cluster. We after creating the EKS, you just get the cluster control plane, and you need to deploy worker nodes that we can do it in various ways. And yeah, that's it. Now, if we go to the compute, you can see we have no any nodes here. And if we check the network part, we deployed our cluster into three public subnets. And keep in mind, you need at least two subnets to be able to deploy EKS cluster. And for the service CIDR block, we assigned this CIDR block. You can check it in our command. This is here. We mentioned the service CIDR block, and the cluster is IPv4 cluster. We can deploy IPv6 as well, that I'll explain how we can do it in future articles. Okay, the cluster is now ready. We can check it in dashboard as well. And now you can see the cluster is ready. We have the API server endpoint, we have the certificate authority, and we can connect to the cluster. To connect to the cluster, we can get the kubeconfig using this command. And now if we check with, for example, get node, right now we have no any node, but we can connect to the cluster. And if, for example, we check kubectl API resources, we can see the cluster is up and running. And if we check, for example, for other commands like help, you can get the help and run any command you want. And right now we can check the cluster info. Yes, the cluster control plane is running, and our cluster control plane is up and running. Now it's time to deploy our worker nodes. Okay, before going for the next article, I want to show you something to investigate which resources are created by EKS in our account. The first thing is the VPC. If we go to our VPC, we can see the security group. This security group is get created by EKS service automatically, and this security group is assigned to the ENIs. We can see the interfaces here. This is the interfaces created by EKS, and that security group is assigned to these interfaces. As well as when we create a new worker node using managed node groups, this security group will automatically assign to all the worker nodes deployed using managed node groups. And if we check that security group, you can see that it's allow all the traffic from this security group itself, which means if we deploy a worker node and assign the security group, the cluster control plane can talk to the worker node, and the worker node can also talk to our Kubernetes control plane. Yeah, that's it. Now we have all the things. This is the result. We created a new cluster. We created a cluster role to allow EKS service to create all the required resources on our behalf, and now we have our EKS control plane up and running. And when we deploy our worker nodes, we can deploy pods, deployments, replica set, and all other Kubernetes workloads into our cluster.